Well, hello there. We are looking at section 4.3 today, which would be the operations dealing with fractions. So we're going to be looking at add, subtract, multiply, and divide. And these are the topics that are included in this particular section. In the fourth grade, we begin adding and subtracting our fractions, and in the fifth grade, we extend that to finding common denominators and multiplying and dividing. And you'll hear these words or these phrases interchange, the least common multiple and the lowest common denominator, because if you find the least common multiple, you are finding the lowest common denominator. And so that's just a difference in terminology, just depending on what it is that you're looking at. So first off, we're going to look at 8 and 12, and we're going to find the least common multiple of 8 and 12. There are several different ways we could do this. We could just start listing out the multiples of 8 and then list out the multiples of 12 and then find those that they have in common and then just start finding them. Let's see, if I choose, get my pen here, then if I choose multiples of 8 that look like, okay, that didn't work. All right, I got it working now. So here we go. There's one, here's one, and to get the least, of course, what we do is just pick out that's the smallest, so our least would then be 24. Now if I wanted the least common denominator, least common multiple of 18 and 40, I could do that same thing again. I could just start listing out the multiples and then find the one that was the smallest that they had in common. Another way to do that would just be to look at the factors of each. So if I look at the factors of each and I know that my least common multiple must contain at least all of these. Let's see, so I'll need I don't need this guy because he's already listed there, but I need all of those. I'll need one of these, and one of these in order to get that least common multiple. But since they have this one in common, I don't have to write that one down. So let's see what that would be. That would be I need at least, I need 3 of these 2s. I need 2 3s because nobody has that in common, and I need one of these 5s. And if I multiply all of that out, I think you'll end up with 360, which is what they get here. And with that same explanation that I was going through. And this is just another way of looking at that same thing. You notice that what I said was since they had this in common, I only needed to list one of those. And so I need to look at everything that they don't have in common, and I need all of those plus only one of what they do have in common is one way to look at it. And they're just looking at this in another way in terms of exponents, but they're still doing it the same way. And here they are carrying on with the prime factorization and saying that they need one of each of those things. And the slides here with the textbook really carried on with that. All right, so now we're going to look at the addition of these two fractions, which is not easy because if I look at 2/3 and I cut a pi into thirds and then I cut one into fourths and I say, well, I've got one of these and then I have 2 of these, how much do I have? Well, I have 3 pieces, but don't really know exactly how much I have because they're not the same size. So what we do when we find a common denominator, and this would be what you would want to show your kids, is you're going to say, well, I cut those pieces into the same size. So each of these fourths needs to be cut into 3, and then, so what I'm doing is just cutting each of these slices into 3. Notice that I have, this makes 12 pieces, and so that's 3 out of 12. If I cut these each into 4, then you'll notice that I will have 3, 4. Then you'll notice, oops, then you can count and see that I have 8 out of 12 of these pieces, just trying to get those pieces the same size with my little crappy drawing. They've got a better drawing, but what we're doing is essentially the same thing. Here they're telling you that you're getting the least common multiple between 3 and 4, and you're counting those pieces of pie, which is what I did, but in a little messier format. Alright, and they're looking at this in terms of the area model as well. That's what this was called. And we also have a linear bar model, in which case I make a bar and I cut it up into 12ths, and then I list off what 2/3 would be, and then I write those down and then add those up without really changing the denominators. But I mean, in essence I am, because I'm having to figure out 1/3 and 2/3 and 1/4 what their common denominator or their least common multiple is, and then I'm still counting. But anyway, they consider it a different model. And then here's just another model. This is the set model. Now in your video that you're going to create, you're going to use one of these models, so kind of go through and pick out one that you like and figure it out and decide which one you think you might utilize when teaching a course. And this set model, it's broken, they said what was common to 3 and 4 was 12, and then they shade in however many dots to make the 2/3 and 1/4, which is the same thing as we did with the linear bar, just a different shape. With mixed numbers and improper fraction, we would call this one the mixed number because it's mixed a whole number and a fraction. This would be called improper because this numerator is larger than the denominator. Subtraction, same kind of thing as addition. It's a little bit difficult because if you're writing your fractions out in this format, 2 minus 4 is actually a -2/5. So that we can avoid looking at negatives, we do the borrowing, and we say, okay, I'm going to borrow one whole pie from this 3, making it 22, and 1 whole pie is 5/5, so that gives me 7 pieces total because I had 2 here, so 2 plus 5, and then subtracting from there. Another way to look at these is to break it apart as this whole number here and see that, which in essence was what we did in order to make it 22 and 7/5. They're looking at this one saying which model best represents multiplication. This is somebody running 2 1/4 miles for 4 times a week, so we're going 2 1/4 and 2 1/4 and 2 1/4, and how far did I go, looking at it in this linear way. A rectangular parcel of land, that's probably going to be area, and then this field trip, this is probably going to be best using that set model. Looking at 2 1/2, if I am to draw 2 1/2, and then so here is 2, if I draw 2 1/2, which it would be this right here, so that's 2 full columns and then half a column, and then I take 3/4 of those columns, which would be this right here. That is a nice way to show students the meaning of multiplication of fractions. And here they are describing that in further detail. Still looking at it as two full, or this is a full one, this is a full one, so there's two full ones and a half, and then taking 3/4 of that. So once we figure out how multiplication works and what it looks like, then we have to come up with a way to do it practically so we don't have to draw that every single time. And they describe that what we do is change this to an improper fraction. That way we don't have to deal with these whole numbers inside of our multiplication while we're trying to multiply the whole number by the fraction and multiply the fraction part. Because this 2.5 really represents, so if we look at it, 3/4 times 2 plus a half. And so what I would really have to do is distribute, and that's the reason why we change it to improper, because I'd have to distribute the 3/4 to the 2, because I want 3/4 of the 2 and I want 3/4 of the 1/2. So in order to avoid that, I just change it to improper, and it makes it easier to understand for students. This is just looking at this in terms of the shaded region and counting regions as well. Equivalent fractions, we talked about equivalent fractions last time. This is justifying why I can multiply top and bottom by the same number and still get the same answer, and that's because in essence what we are doing is multiplying by a 1. And a 1 can also be represented as 2/2, because 2/2 is also 1. And that's just showing us doing that. And this is the general case, which no one wants to see because it's all done in letters. Division of fractions, I like this little saying, but here's a famous saying: ours is not to reason why, just to invert and multiply. And I do remember seeing that and hearing that whenever I was in school. So we don't want to respond to students in that way. We want to kind of show them why, when we divide by a half, why we invert and multiply. So let's just say that we were looking at, let's say, 3 divided by half, because I can actually possibly draw this. So I'm going to divide from 0 to 3. I'm going to divide this into partitions of a half. Oops. Oh, that's getting a little messy. Let me redraw. Okay, this looks a little better. So I divided 3 into partitions of a half, and I need to know how many of those that I have. So each of these was partitioned, and I have 1, 2, 3, 4, 5, 6 of those partitions. And I would have worked this with the invert and multiply to get my 6. So that's one kind of visual on division of fractions. They talk to you about the multiplicative inverse. Additive inverse is whatever you can add to get your identity. Multiplicative inverse is what do you multiply to get 1, and means you get the identity back. That's what it means to be an inverse. So there are two different inverses when you talk about numbers. There's an additive inverse and there's a multiplication inverse. For addition, it's what do you add to get 0, and for multiplication, it's what do you multiply by to get 1. So there's not just one inverse. You have to ask, if someone says give me the inverse, you have to say, I have to ask them the question of what, multiplication or addition, because they're two different numbers. Here they are just showing you divide by fractions, and they're just saying it in terms of math, that well, what you're really doing is multiplying by the inverse. And I don't really know that that's a great interpretation, but it is one that is valid, and mathematicians use that one. So let's see what this problem is about. We're going on a trip 120 miles away, he runs out of gas if you've gone a third of the second half of the trip. So let me try and draw this. Okay, so his car ran out of gas after he had gone 1/3 of the second half of the trip. So then my pencil went away whenever I went to draw. So pencil, pen. Okay, so he goes 1/3, so I can bust this into thirds when he's gone a third of this distance. Then he's sitting there out of gas. So let's look at this in terms of this is 3 out of 6. This would be 4 out of 6, 5 out of 6, and then this would be 6 out of 6 because that's the whole trip. So he has gone 4/6 of the way. So what does he have left? He has 2/6 left, so he actually has 1/3 left. So that's all that we have for 4.3. If you need anything from me, if you need an extension on any of the homework, or if you want me to work the problems, be sure and ask me for Collaborate, and I'll be happy to get that done for you. Bye now.